Hi everyone, my name is Stia Metric number 291957. Now our group will start the presentation. This is our group member introduction. The healthcare industry handles a large amount of patient data on a daily basis, so having an efficient system to manage and process this information is critical. So, a digital solution is needed to replace a paper-based patient management technology. This is our objective. To save the time, we will jump into the more important part. Data structure concept. In this project, we have used the linked list that we learned in data structure class. A linked list is a data structure consisting of nodes connected by the reference. Each node holds data and a reference to the next node. The first node is called the header and it provides access to the linked list. Linked lists provide dynamic memory allocation, efficient insertion and deletion feature and more. They are commonly used to store and manipulate collection of data. We have created a node class. In this class, we have two public attributes that is patient represent patient object stored in the node, and next it represents the reference to the next node of the linked list. The class has one constructor that used to initialize a new instance of the node class with the provided patient object. Medical class also have a two private attribute and a one constructor patient. Based on the code, it creates a new node object called new node and initialize with the patient object passed to the method. It checks if the linked list is currently empty by checking if the first node is null. If the linked list is empty, it assigns new node and both of first and last node, making it only the node in the list. If the linked list is not empty, it assigns new node as a next node of a last node, efficiently adding it to the end of the list. In summary, the add patient method applies the linked list concept by adding a new node to the end of the list and updating the necessary reference to maintain the integrity of the linked list structure. Remove patient. Based on the code, it initializes a reference variable current with the first node of the linked list. It enters a while loop of continuing as long as the current and current next are not new now, allowing it to traverse linked list. Within the loop, it checks if the name and age of the patient stored in the next node of the current node match to the given name and age criteria. If it's matched, it will update the reference and remove the node containing the matching patient by bypassing it and linking the current node to the node after it. If the removed node was the last node in the list, it will update the last reference to the point of the current node. So the remove patient method utilizes the concept of traversing a linked list and modifying the node reference to remove specific patient. It iterates through the list, updating the link between the node bypass the node containing the matching patient. The method efficiently demonstrates the core idea behind removing element from the linked list. So now I will pass to the next group member.
My name is Lim Zhengwei, metric number is 293142. So right now I will present about the search patient that had used the linked list. The display a patient method check if the first node of the linked list is not null and if the patient name in the code matches the search parameter. If the search is found, it prints the patient's information. If not, it traverses the linked list using a loop, checking each node patient name for a match. If a match is found, it prints the patient information and exits the loop. After the loop completes, the method execution ends. Next. Display all patient. The display all patients method also using the traverse concept in linked list to print the information of all patients stored in each node. It starts by initializing a reference variable current with the first node of the linked list. Then it enters a while loop that continues as long as current is not null. Within the loop, it prints the patient's information stored in the current node. After printing the information, it updates current to refer to the next node in the linked list. This process continues until the end of the linked list is reached, which is current becomes null. So next. So right now I will keep talking about the linked queue that had used in our project. So what is linked queue? In a linked queue, each node of the queue consists of two parts, which is data part and the link part. Each element of the queue points to its immediate to next in the memory. In the linked queue, there's two pointers maintained in the memory, which is front pointer and rear pointer. Next. So I'll keep going to the process next patients. The court first check if the first node of the linked list is not null using the condition first node equal to null. If the condition in step 1 is true, it means that there is at least one patient in the queue. The court assigns the patient object stored in the first node to a variable called next patient using the statement patient next patient equals to first dot patient. This variable represents the patients that will be processed. The court updates the first reference to point to the next node in the linked list using first equal to first next. This effectively removes the first node from the list, making the following nodes to the new first node, means pop. And the next is the court check if the update first reference is null, indicating that there are no more patients in the queue. If it is null, the court updates the last reference to null as well using the statement last equal to null. This ensures that both the first and the last reference are consistent when the last patient is processed. The court prints a message indicating the processing of the patient along with their information using output set text processing patient plus next patient. If the condition in step 1 is false, it means that there are no more patients in the queue. In this case, the court will print out the message which is no more patients in the queue by using the court system print line no more patients in the queue. Once the processing is complete or the message is print, the process next patient method execution completes. Next. So I'll pass up to the next presenter.
Hello, my name is JIAN, and now I'm going to present for the explanation of medical system program. The node class is represent a node in the linked list. It contains two public instance variable, patient, which stores the patient object, and next, which points to the next node in the list. The node class has a constructor that takes a patient object as parameter and assigns it to the patient variable. The next variable is initialized to none. Now, next please. The next is the patient class. The patient is a user-defined class that represents a patient in the medical facility. It has three instance variables which are name, age, and disease. The constructor takes three parameters, name, age, and disease. It initializes the corresponding instance variable with the private provided values. The getName method returns the name of the patient. The getAge method returns the age of the patient. The toString method overrides the default toString method provided by the object class. It returns a string response representation of the patient's detail, including their name, age, and disease. Next. The medical class is a user-defined class that represents medical facilities. It manages a list of patients and a queue for patient processing. The medical class represents the medical queue and contains two private instance variables, first and last, which are the reference to the first and last node in the queue, respectively. The node class is a private inner class that represents a node in the linked list. It contains two instance variables, patient, which store the patient object, and next, which point to the next node of the list. The add patient method adds a new patient to the end of the queue. It creates a new node object with the given patient object and updates the first and the last reference accordingly. Next. Next is the remove patient method. The remove patient methods remove a patient from the queue based on the given name and age. It iterates over the linked list and checks if the next node's patient match the provided criteria. If a match is found, it removes the node by updating the reference accordingly. The display patient method display the information of the patient with a specific name. It checks if the patient methods match the search criteria and display it. Otherwise, it iterates over the linked list to find a match match and display the patient's information. Next. The process next patient method. If there is a patient in the queue, it assigns the patient object of the first stop patient to the variable next patient. The first reference is then updated to point to the next node in the linked list. First equals to first dot next. This effectively removes the first node from the queue. Overall, this code segment handles the processing of the next patient in the queue. It updates the appropriate reference, retrieves the details of the next patient.
My name is Kudada number matrix 292973. Now I will continue to explain the GUI interface for the medical system. From the picture in the slide that show the design for the GUI system, and there are some text field to let the user key in the information, which is name, age, and disease. After that, there are also some buttons that can be used, which are add, delete, next, search, and display. Lastly, the information will display in the text area. Next, please. Now I will explain the source code in the add button. This code retrieves the values entered for the patient's name, age, and disease from the corresponding text fields or components, which are name, age, and disease. It creates a new patient object using the retrieved values. Then a new node object is created using the node class from the previous discussion, with the newly created patient object as the constructor parameter. Overall, this code segment adds new patient to the linked list by creating a new node object with the patient's information and updating the appropriate reference based on the state of the linked list. Next. This is the source code in the delete button. This code retrieves the values entered for the patient's name and age to be deleted from the corresponding text field or components. It initializes a Boolean variable removed to false to keep track of whether the patient has been successfully removed. If the patient to be deleted is not the first one, the code iterates over the linked list starting from the first node. It checks if the patient name in the list match the provided name and age. If the match is found, the current node's next reference is updated to skip the next node, effectively removing the node from the linked list. If the removed node was the last one, the last reference is updated to the current node. Overall, this code segment handles the deletion of a patient from the linked list based on the provided name and age. Next. This is the source code in the process in the next button. If there is a patient in the queue, it assigns the patient object of the first node to the variable next patient. The first reference is then updated to point to the next node in the linked list. This effectively removes the first node from the queue. Overall, this code segment handles the processing of the next patient in the queue. It updates the appropriate reference, retrieves the details of the next patient. Next. This is the source code for the display button. If the patient list is empty, the output text component is updated with a message indicating that the patient list is empty. If the patient list is not empty, the output text component is updated with an initial message indicating that the patient list is being displayed. After appending the patient information, the current reference is updated to point to the next node in the linked list, moving to the next patient. The loop continues until all the patients in the queue have been displayed. Overall, this code segment handles the display of all the patients in the linked list. It checks if the list is empty, updates the output component with the appropriate message, and iterates over the linked list to append the string representation of each patient to the output component, and display them one by one. Next. This is the source code in the search button. This code retrieves the value entered for the patient's name to be searched from the corresponding text field or component. If the first patient matches the search criteria, the output text component is updated with a message indicating that the patient has been found, along with the details of the first patient. If the first patient does not match the search criteria, the code enters a loop iterate over the linked list starting from the first node. Inside the loop, if check if the name of the current patient match the search criteria. If a match is found, the output text component is updated with a message indicating that the patient has been found, along with the details of the current patient. Overall, this code segment handles the search for a patient in the linked list. It iterates over the linked list, checks if each patient matches the search criteria, and displays the patient's information. Next. This is the output for the add button. Next. This is the output for the delete button. After that, this is the output for the next button. Then this is the output for the search button. And lastly, this is the output for the display button. And that's all for our group presentation. Thank you.